Alright, this is homework for 1.2 and just a couple of things that people got stuck on, so I'm kind of just rewriting it real quickly here and doing the work. And so we have this that we have to solve, and whenever you see a y squared or a y, what you want to do is you want to just move things over so you have everything all on one side, and that's and you have it set equal to 0 because you're going to factor. That's what you want to do. You want to be factoring here as we go about doing it. And when you do that, add this up. Now these should all cancel. You should have a 0 here. That's the whole point. 7 minus 4 is a 3. 13 minus 6 is a 7. And 6 minus 3 is a positive 3 equal to 0. Alright, and then here you have some choices here. You can either do just the factoring the regular way. Alright, and the other choice is you have quadratic formula. Just put QF, quadratic formula. Those are the two that we normally think about when we do this there. So try to factor this easily, see if it does, and if it doesn't, then we're going to go on to factor. The only sort of guess that I can maybe possibly make is this being a 3y, this being a y. That would be 3y squared. Let's see, minus... In order to get a plus over here, these guys would have to both be minus. And I'm thinking to myself, most likely it's not going to work out. If I have 1 over here, that's a negative 3y minus another one would make a negative 10y. That's not going to work. And the other one's not going to work either. So I have to do the quadratic formula at this point here. So let me just write it so I have more space here. And the quadratic formula is going to say, hopefully you guys know it, look it up if you need to, negative b. So it'd be a negative of a negative 7 plus or minus the square root of b being squared minus 4 times a times c all over 2 times a. So as we can solve that, we'll be in good shape. That's going to be a 7. That's going to be a 49, looks like 49 minus 36 all over 6. Go a little bit more, plus or minus. That's going to be 13 over 6. Alright, so at this point what you want to do is you want to write it out as far as answers go. You want to write it as 7 plus the square root of 13 over 3. Once you set that up, then you're going to do another one here, 7 minus the square root of 13 over 3. So, I need some water. No, I need some water. Just a little bit of water. Do that on your stomach like that. I know I'm not as good as you, but Alright, next one here to solve is still coming from chapter 2. And we have to solve this right here. So first thing I would do, again, move things over. Let's move that 32 over to be on this side. And the question to ask ourselves really is there a number that goes into 9, 12, and 32? Thinking probably not. I don't think there is. Alright, as we said before, factoring is a possibility. If factoring doesn't work or you don't want to go on with factoring, you can always go to quadratic formula. In this case, I'm going to just try, just possibly. The two ways I can get a 9x squared is 9x times x or a 3x times 3. And that's my two possibilities. Oh, we get a 32. Wow, there's a whole bunch of different ways I can get a 32. 1 and 32, of course. 16 and 2. Let's see, 3. Can I get a 3 out of it? No. 4. Yeah, 4 and 8. So now the question is there any way that I can do this so I get a positive 12 in the middle? Positive 12 in the middle. 18. 32 minus 8, that's 72. Nope, that's 12. I'm just kind of randomly working out things in my head here. I'm thinking maybe this kind of gets close here. Let's go 8 here, 4 here. And what I kind of did is I put in a 32 and a 1 and I tried it in my head. Because the top or the outside and the inside, after you do the work, have to match each other. So it's almost like a guess and check. You plug this in, see if it works. And if it doesn't, you erase it and you go on with another one here. So you put a 16 here and a 2 here and just see if that's going to work. And that's no way, that's too big. And then you say, okay, let's do it the other way. How about a 2 here? Let me fix that. How about a 2 over here? 16 there. That makes an 18x. That's a 16x. Ooh, one of them has to be minus sign, sorry. Let's do this as a minus 16. And that's going to be a 2x. I need a 12x. So if I do this, keep on doing this in my head, I find out that 4 and 8 just might work. I think I want this one to be the positive one, this one to be the negative one. So let's check. Let's check the outside terms. That makes 24x. That makes minus 12x, and it does work. Perfect. Okay, that's what I want right there. So the one that works is 3x minus 4. 3x plus 8. I'm going to split those off into individual pieces. And I'm going to add 4 divided by 3. So I have 4/3 as an answer. I'm going to subtract 8 divided by 3, and I got that one. So there's my two answers. As you put it in, put 4/3 comma negative 8/3, and you're good to go. Next one. This one is solve each equation by multiplying both sides by the LCD. So let me bring it over here to do the work. Alright, this one is the easy one. This one, notice there's no exponents over here anywhere. So we call this cross multiplication. The easiest way to start solving it. Let's cross multiply these two together. Across. The only thing before we do that, we have to sort of ask ourselves, what can x not be? If we get this answer for x, we can't use it as our answer. So it's whatever's going to cause a 0 on the bottom right here. So if you have a hard time trying to figure what that is, what you do is you just set that little guy equal to 0. 3x minus 2 is equal to 0. When does that happen? If I add 2 divided by 3, it happens at 2/3. So x cannot be 2/3. So if I have 2/3 as an answer, if I get 2/3 as an answer, I'm going to have to disqualify it, because you can't have 0 in the bottom of fractions here. And then this one right here. The question is, when is that going to give me a 0? 3x plus 2 gives me a 0 if I subtract 2 and I divide by 3, or a negative 2/3. So if I get a positive 2/3 or a negative 2/3, any one of those, I'm going to have to discount those as answers. Okay, now let's go for it here. So let's cross multiply the x plus 1 with the 3x plus 2. Then we're going to also cross multiply the 3x minus 2 with a 5x minus 4. And let's go for it here just real quickly here. Multiplying these out, this should be a 3x squared. This would be a 2x plus 3x makes 5x. And a 2 times 1 is a 2 at the end. Over here, this would be a 15x squared. Let's see, minus 12x. This would be minus 10x, so minus 22x. And then we got ourselves a plus 8. Alright, so let's move things around. I think it's easier to move all this stuff over here. It'd be easier to do that because the x squared would be positive here. So minus 3x squared to move it over, minus 5x, minus 2, which is going to be the end product here. I'm running out of room. So let me bring it up to the top here. This is 0, according to the right-hand side, because that all became 0. 15 minus 3 is going to be a 12x squared. 22 minus 5 makes a minus 27x. And this will be a minus or plus 6. And I noticed that all of them have a 3 in common. 3 can go into that one, 3 can go into that one, and that one. So let's divide everything by 3. 0 divided by 3 is still 0, but this makes a 4x squared minus 9x plus 2. Alright, guess and check for the factoring technique, or just possibly, can we get something that works here? So I'm going to go with 4x times x to give me that 4x squared. So now the question is, can I get 2's at the end so that in the middle I get a minus 9? So first I'll look at the signs. Notice this is a plus 2, this is a minus 9. So I know both of them will have to be minus to get the middle to be a minus and the outside to be a plus. And then I'm thinking to myself, probably a 2. If I put a 2 into here, look, notice what's going to happen. This will be a negative 8x. And this would be another negative 1x. That'd be negative 9x, which is exactly in my middle. Perfect. Okay, set each of them equal to 0 and solve. Add 1, divide by 4, which gives me a 1/4 as my answer. This would be adding 2 to both sides. And the only thing is we've got to check, can I accept both answers based upon that? Yes, I can. So here it is. Two answers are 1/4 and 2. That's the way you should write it in that little box there. Alright, now we're moving on to ones that have a square root inside them. And so the way we get rid of a square root is we have to square both sides. Alright, so before we can square both sides, we got to have this little square root all by itself on one side. Can't do it any other way. So we'll have to subtract this little x out. That goes away. We're left with a square root of 2x plus 35 is equal to negative x. There it is. That's where we're at. Alright, what we're going to do here, we're going to square both sides just like that. Okay, when you square root something, you square something, all that happens here is that those two go away. On this side, you get an x squared. So let's do this here. Let's move everything over. The 2x goes over, the 35 goes over, and we're left with 0 is equal to x squared minus 2x minus 35. And the question is, can you factor that? What do you say? I'm thinking, how about a negative 7 and a positive 5 would do it. There it is. Alright, the easier way to do it is you take this negative 35, put on top, take the minus 2 and put it on the bottom, and the question is this: what two numbers would multiply to give you negative 35, would add to give you negative 2, and that's going to be a negative 7, positive 5, which is what we got here. Cool. We set each of them equal to 0. And we get ourselves an answer of 7 over here and a negative 5 over here. Now, the only thing is, if you guys remember from your algebra class, here's what you had to remember from your algebra class. If you are the one that is squaring both sides of an equation, what you have to do is you have to always check your answer, because you could have possibly, maybe, introduced answers that were really not there in the first place. So you always have to check. Always, always. So let's go back to our original problem, and we're going to check x equals 7. So we say 7 plus the square root of 2 times 7 plus 35. Will that give me a 0? Now that's going to be what, 14? 14 plus 35, that gets me a 49. And that gets me a 7 plus 7. That's great, but it's not what I want. So 7 does not work. So let's try negative 5. Let's see if I can squeeze it in right into there. Will negative 5 work? Negative 5 plus the square root of 2 times negative 5 plus 35. Will that give me a 0 eventually? That'd be a negative 10 plus 35 is 25. And the square root of 25 is 5. Negative 5 plus 5 is a 0. That one works. Perfect. Okay, so our only answer is negative 5. That's the one you should write into there. Negative 5 as our answer. All right, now this one. Oh, it's very similar to the previous one. Actually, I'm going to skip it. It is very, very... No, sorry, can't skip it because that last one has a 0 here. This one has a minus 5. It's a little bit more complicated here now. So let's go for it here. Let me rewrite it. This would be a little bit of a long problem here. Okay, but it's going to work just like the previous problem did. Okay. Or very similarly. Let's go for it. So first things first, we got to get this little square root right here all by itself on one side. That's it. So we're going to subtract the 7t. Subtract the 7t on this side. So you got a negative. This is a negative t minus 5. All right, almost done. Not quite. I got this little minus sign right here. So let's just divide both sides by negative 1. And I got myself the square root now all by itself on one side. That's fine. This is going to just get opposites here. So it's t plus 5. So negative of my t, negative of my negative 5. Or negative 5. Alright, so here's what we're going to do. Just like we did last time, let's go for it. We're going to square both sides right here. So this will be 6t minus 30. The other one is not so fun. T plus 5, and if you know the little trick here, there's like a little shortcut trick here. If you don't, then you have to FOIL this all out. So t times t is t squared. T times 5, 5t. Another 5t makes 10t. 5 times 5 is 25. There it is. So I have myself a t squared plus 10t plus 25. Alright, now the process begins. I see a t squared over here. Therefore, I'm going to be factoring our quadratic formula, just based upon what's happening here. But I think it's easier to bring the 6t plus 30 to this side here. So I'm going to do that. I'm going to bring them over. Once you cross the equal sign, they have to change signs. So there's that, and there's that. All right, running out of space here. So let me go all the way up here. So I got a 0. Let's see, t squared minus 4t, no, plus 4t, because the positive was on the 10. It's a minus 5 over here, though. All right, and the question is, does this factor? I think so. I think that's an easy factoring, actually. This is going to be a plus 5 here and a minus 1. That'll give me a positive 4 in the middle. All right, and if you solve it, gets me a negative 5 from here. Gets me a positive 1 from here. But then what do we have to do? If we did this, if we squared both sides, we have to check it. So let's check. Does negative 5 work? And we always have to go back to our original problem. So negative 5 minus the square root of 6 times negative 5 plus 30, will that give us negative 5 at the end? Maybe. We'll see. Hey, that gets me a negative 30 plus 30, which gives us square root of 0. And the square root of 0 is just 0. And that works. Okay. That works. Let's check 1. Let's see if 1 works. 1 minus the square root of 6 times 1 plus 30. Will that give me a negative 5? Let's see. 6 times 1 is 6 plus 30 would be 36. And the square root of 36 is 6. And 1 minus 6 is a negative 5. Oh, that's so cool. So in this case, both worked. So what you're going to write inside here, you're going to write negative 5, comma 1. Those are the ones that worked. All right, this one, how's this one different? It has 2 square roots. So I've got to deal with 2 square roots at the same time. The process is still exactly the same as previously. The only problem is we've got to work with 1 square root at a time to get this all solved. So here's what we do. Just like on the previous 2 problems, we had to get a square root by itself. You get to decide which square root you want by itself first. So here's what I'm going to do. I'm going to take this 2x plus 3 here. I'm going to scoot it over because I want this one all by itself. Alright, so let's see how this is going to happen here. This is the square root of 3x plus 10 equal to 2 minus, because we moved it to the other side, the square root of x plus 2. Alright, so what are we doing here? We are getting rid of the square root on the left-hand side, because those are going to cancel. And this one's going to be a little bit more difficult to do, but that's okay. On this one, the square root does not cancel. We're going to have to sort of work this out a little bit on the side. And you'll see the advantage that we have done over here. So if we multiply here, this would be a 4. This would be a minus 2 of these guys. Another minus 2 of these guys. At the end here, negative times a negative is a positive. And this one, the square root of x plus 2 times another square root of x plus 2 just gives us x plus 2. So I'll show you sort of the advantage here in just a bit here still. Notice you got this little 4 here and this 2. Let's add those together. So that's 6. The little x right here, that's by itself. You get x. And then adding these guys together. Negative 2 of those, another negative 2 of those gets you negative 4 of those. So the question is, Mr. H, how does this even help us? Well, notice when we started off in the first place, there was 2 different types of square roots here, right? As we come down here, now notice what we have is we just have one single one. So by this process, we have eliminated one of the square roots. That's a good thing. Except for the fact we got to do it again. We've got to do this again. So we're going to have to get this guy by itself as much as we can, and then do the same process again, which is square it. So let's go for it here. So subtract 6 here. Subtract x here. So 3 minus 1 is a 2. 10 minus 6 is 4. I got a negative 4 over here and an x plus 2. Alright, that's about as close as we can get it. Now you can say, Mr. H, we still have this little negative 4 on the outside. That's true. But if I were to divide both sides by negative 4, I'm going to have fractions here. That's going to get even worse and ugly. So this is okay as long as you don't have a plus or a minus in between the negative 4 here. Okay, so let's see how this is going to happen. I'm going to square that side. I'm going to square this side. Okay, squaring this side here. Do it off to the side on a sheet of paper if you like to here. do a FOIL method here, but it should give you 4x squared, let's see, plus 16x plus 16. On this side, what's going to happen is that little exponent is going to work on the negative 4 to get you a 16. And as it works on the square root over here, it's going to cancel this. So you're left with 16 now. Notice what we did is we squared the negative 4 to become a 16. And then we squared the square root of x plus 2, which causes the square root to just be canceled. Okay, that's what we've got to work with now. So just to simplify matters, let's distribute. 4x squared plus 16x plus 16 gets you 16x plus 32. And let's move everything over to this way. Hopefully we have room here. So let's see, 16 minus, ooh, that's going to be 16 minus 16 over here. That gets canceled. And minus 32 over here, 16 minus 32 minus 16. Okay, so there's kind of two different ways to handle this if you like. You can factor out the 4 if you like, or you can move that 16 back to the 0 here. Normally we do it like this. We are going to factor out the 4, left with x minus 4. Then we divide both sides by 4, because that's going to cancel this little guy in front. Now we're left with x squared minus 4. And then we factor this down to a plus 2 and a minus 2. And so then our answers are x is equal to 2 and a minus 2. Now, did we square both sides? Yes, we did. Remember, we actually did it twice. Notice right here. We squared both sides? Yes. Right here. Did we square both sides again? Yes. So we did it over here as well. Whew, okay. So we're going to have to check. So let's check x is equal to the positive 2. Let's check the positive 2. So plugging in the positive 2 back into the original equation. 2 plus 2. Another square root of 3 times 2 is 6. I'm going to put 6. 6 plus 10. Does that give me a 2? Let's check it out. So 2 plus 2 is 4. Oh. That's going to be a 16. That's going to be a 2 here, a 4 there, and that does not give me what I want. Alright, so let's check the negative 2. So square root of let me do this again here. So square root of 2 plus 3 times negative 2 plus 10. Will that give me a 2? Let's see. Negative 2 plus 2 is a 0. This would be negative 6 plus 10 is a 4. 0 plus 2, that does work. So, okay, so then it means negative 2. Negative 2 is the only thing that worked here. That's the one that we want to put in. Alright, this one, these are called factoring in form. What we do is we do something called U-Substitution in order to make this work. So let's talk about it first. In order to make this work, normally whenever we factor stuff down, we have something that looks like this. Like this stuff, we know how to factor. We've seen this all throughout algebra right over here. But notice the exponents here. Notice the exponents are a 2, then you have a 1, and then you have a 0. Notice how they go down. They go down by integers from 2 down to 0. That's what we want to happen here. Okay. So as we notice for this first one here, you have x minus 12 square root of x. And the little thing that sort of gives it away is, notice this one has to be an exponent of 1. So almost all the time, what you have is I'm going to do a U substitution on this guy, and this guy is going to be my U. And this one's a tricky one. Some students get stuck in because they say, Mr. H, how could that be I want this guy to be a square of the u. Is that true? Yeah. Let's take a look at it here. If you have x by itself, isn't it the same thing that saying this? Isn't that really the square root of something squared? We just did in the last 3 problems here. Remember, if you square a square root, these guys will cancel off, right? So there's that little trick just to notice if you have x by itself, it's technically a square root of x being squared. Okay, how does U-substitution fit in? There it is. If that is the case, that's the u right there, and it's being squared. Minus 12u plus 27. Okay, so what we do is we factor. Let's see, I need 2 numbers. Multiply 27, add to 12. Oh, 9 and 3, that would work. 9 and 3, both negative. Okay, that's good. Okay, so then when we solve this, notice that we're not solving for x, we're solving for u this time. So add 9 to both sides gets you that. Add 3 gets you this. Okay, and here's our little problem. Our problem is originally we did not have a u as our variable. We had an x as my variable. So what we do here, this is called U-substitution. Okay. Over here it's called back substitution. So what we do is we back substitute what we were solving for in the first place. So in this case, let's see, this is what we need right here. U is the same thing as x squared, or the square root of x. So now this changes back into the square root of x is equal to 9. We can do the same thing over here. This would be now the square root of x is equal to 3. And let's solve each of these. We're going to square this side, square this. Ooh, hold on, we're squaring both sides again, right? So we're going to have to check these answers to see if they're really legit or not. So I got myself an 81. Going over here, I'm going to do the same thing. Square this one, square this one. Since I'm squaring both sides, I'm going to have to check my final answer just to make sure it works. Alright, so let's check here. I got myself an 81 minus 12 times the square root of 81 plus 27 will give me 0. Let's see, the square root of so 81 is 9. 9 times, that's going to be 108. And if I were to add 81 plus 27, that will give me 108. So 108 minus 108 works. That's cool. Okay. 81 works. I wonder if 9 works as well. Let's check it out. So 9 minus 12 times the square root of 9 plus 27. Will that give me a 0? Let's check it out. The square root of 9 is 3. 12 times 3 is 36. 9 plus 7, just going to add all the positives together. That gets me 36. And 36 minus 36 is 0. Both of them work. That's perfect. So inside here, you're going to write 81 and 9, since both work. Alright, now these ones are the funny ones here. You have, again, like we said last time here, you want a variables or your exponents to be a positive 2, positive 1, and then 0. That's for the exponents each time when you do this. Now you have yourself a negative 2, a negative 1, and 0. So how do we handle that? Alright, so we're going to have to do again a U-substitution somehow. Okay, so again, what this means here is we're probably going to do that. And we're going to see if this is true. Is this still a square of u? And I think so. This will be same thing as, let's see, -1. This would be x to the -1 being squared, right? And that, oh, sorry, -1 right there. Cool. Okay, that works. So this will be u squared plus 6u plus 5. There it is. Okay, so can I factor this down? Absolutely. I'm thinking a +1 and a +5 would make +6 in the middle. U is equal to -1. U is also equal to -5. As we solve it, let's bring it up. All right, and we're going to back substitute this stuff, right? So back to the x. That means this. All right, and you guys tell me here, what does that little -1 in the exponent mean? It means reciprocal. That's what it means. So if we take a -1 of this, and we take a -1 of this, we're just going to take the reciprocal of that. We're going to take reciprocal of that, which becomes this, which still becomes -1. So -1, +1, they're reciprocals of each other. This one, on the other hand, back substitute the x to the -1 in here. Take it to the -1 power, which means reciprocal. And you get yourself a -1/5, which is the reciprocal of -5, which is perfect. There's our two answers. So inside here, -1, -1/5 are two answers. All right, and again, making the appropriate substitution. I'm going to write this out again. So 2x to the 1/2 plus x to the 1/4 minus 6 is equal to 0. I'm going to substitute this guy as the 1/4. Usually it's the middle one. So now the question is this technically, truly a square of x to the 1/4? Yes, because of that, right? 1/2. 1/4 times a half is going to be, 1/4 times 2 gets me a half. Perfect. So that's going to come in. That's going to come in as u squared plus u minus 6. And then this one's a little bit more complicated to factor, but I think we can do it. Only way you get a 2u and u squared in front is a 2u times u. Question is, how do you get 6 at the end so you get a 1 in the middle? I'm thinking like a 2 and a 3 probably. I'm thinking like a 2 here, positive, because that'll give me a 4u minus 3u. So 4u minus 3u gives me a positive 1u. Perfect. Okay, let's go over here and solve each of these here. So for this one, I think you add 3 to both sides, divide by 2. That's cool. This one you just subtract 2. So we have the u solutions as 3/2, and the u solution is -2. We're going to back substitute this in. Back substitute that in, and then we're going to take powers. So this is the 4th power. That's crazy. This is 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 81. 81 over 16, because 2 times 2 times 2 times 2 is 16. This one's going to be to the 4th power. -2 times -2 times -2 times -2 is positive 16. Okay. Now, last 2 times we squared things, right? This time we're taking it to the 4th power. And if you're taking things to the 4th power, once again, you have to check. You have to check your answers. So you have to back substitute all this in. This is the fun part. I have to back substitute this in. So 81 over 16 to the 1/4 plus 81 over 16 to the 1/4 is here, minus 6 is equal to 0. Is that true? Well, half of that, right, or the square root of 81/16 would give us 9/4. A fourth of that, well, we just took the fourth power here. These two are connected to each other because if you take it to the fourth power, you take it to the fourth root, it'll get you back to what you had before. Alright, in this case, I think we're good here. This will be a 2 here, so this is 9/2 plus 3/2 minus 6. The question is, will that get you 0? Yes, it will, because 9 plus 3 is 12. 12 divided by 2 is 6, and 6 minus 6 is 0. This one works. Let me go to the top since I'm running out of room here. Plugging in a 16 into here. 16 taken to the exponent of 1/2. 16 taken to the exponent of 1/4. So square root of 16 is 4. Fourth of a 16 is 2. The question is, does that work? 8 plus 2 minus 6, so that gives me a 0. That does not work. So we scratch that out. Only answer here is 81 over 16. Alright, this is making the appropriate substitution here. And notice the powers are, it goes from 4 to 2 to nothing. So it's kind of like it goes 4, 2, and 0. We don't want it to go that way. We want to go from 2 to 1 to 0. And the advantage is that we want this guy to be an exponent of 1. So that's our U-Substitution. That kind of gives it away. Once we set that, we ask ourselves the next question. We ask ourselves the fact that, does that fit to be a perfect square of the previous one? I think it does. If you put a 2p squared into here, you're going to have to square it again over here to get you that 4. And if you do, that's your u right there. So we've done a U-Substitution of 2u squared plus u minus 1. And the question is, can we factor this down? 2u times u has to be there, and I'm thinking a positive 1 here, that gets me a 2u, a minus 1 there, that gets me minus 2, that gets me the u in the middle. Perfect. Okay, solve that. So u, if you add 1 to the first parenthesis, divide by 2, it gets me a 1/2, and the other one is a negative 1 if you set equal to 0 and solve. Alright, let's back substitute what we have here. This is p squared because originally we're solving for p. And in order to finish this off, we have to take a square root of this stuff. Alright, what is a square root of a 1/2? Alright, we'll have to do that here. Let's see. We're going to do p is equal to, you can split the top and the bottom into two different pieces. This will just give me a 1 on top. In order to rationalize our denominators, we're going to have to multiply both top and bottom by the square root of 2. And it turns out this guy is the square root of 2 over 2. There it is. There's one answer. Alright, we're going to take a square root here, and we're going to take a square root here. And if you do that, you're going to get yourself p is equal to, if you guys remember from all the way from algebra, this is just I, is that right? It's a complex number. So for this one, you're going to deal with, in pre-calculus, for most of the time you're going to be dealing with the real numbers. So we're just going to use the square root of 2 over 2 as our answer. Alright, another U-Substitution here, and you can pretty much clearly see what we're going to substitute here. The middle term, This big guy is just our u right there. And you can clearly see it because if that's u, this has to be u, and then you have yourself u squared plus 2u minus 3. Again, this is just a process to make this just really quick for factoring purpose. That's it. Just a quick factoring purpose thing. All right. Let's go with factoring this guy down. So I'm thinking a plus 3 here and a minus 1. That's what I'm thinking. That would work. 3u minus u makes 2u. Yep. And solve it. You get u is equal to 1. U is equal to negative 3. So u is equal to 1. U equals negative 3. Now we're going to back substitute. 1 plus the square root of x is equal to 1. Over here as well as over here. 1 plus the square root of x is equal to 1. Alright, solve these guys now. Now there's actually a little bit more to solve over here. Solve this one. If you subtract both sides here, you get a square root of x is equal to 0. Ooh, and then guess what we're going to have to do again? We're going to have to square. So you get x is equal to 0. Oh, I messed up over here. Sorry, this should have been a minus 3 over here. So if we subtract 4 from 1 from both sides, we get ourselves a negative 4. We're going to have to square both sides again, and you get x is equal to 16. Now what we have to do is we have to check our answers. I'm not going to check it for you. I've been doing plenty of checking already here. Check your answers. Plug this into the original problem. See if 0 works. Plug this into the original problem. See if 16 works. And whichever one works, that will be your answer. All right. Another substitution. Here it is. Again, very clearly defined what's going to be the u value. That's pretty easy to see. The u value is going to be right there. And that's going to be that u, so negative 4u over here, and this one's squared, so that's perfect. So this becomes u squared minus 4u minus 5, and that is a factoring, pretty easy factoring concept there. Two numbers multiplied to negative 5, add to negative 4. Those guys are going to be a negative 5 and a positive 1. And its solution form, it's going to be y is equal to, u is equal to 5, u is equal to negative 1. Bring it up here. And we are going to back substitute all this all together here. So u changes back into x squared minus 3 is equal to 5. X squared minus 3 is equal to negative 1. Alright, and we're going to add 3 to both sides. Gets me an 8, and you take a square root of 8 plus or minus, and that should give me plus or minus root 2. Oh, sorry, 2 root 2. Because if it's 4 times 2 to give you an 8. Alright, on this one, as you add 3 to both sides, gets you an x squared is equal to 2. And as you take a square root of both sides like this, you get plus or minus on this side, and you get yourself a plus or minus square root of 2 only. Alright, we never squared both sides of an equation, so that's good. So all those answers would work. And the way the answer wants you to separate is don't put plus or minus in front of things here. So this would be a positive 2 root 2, then write a negative 2 root 2, then positive root 2, and then a negative root 2. So they want you to separate them out into 4 different pieces, typically. Alright, another one similar to that one. So U-substitution is going to be this piece right here. Therefore U-substitution here, and we got ourselves an answer of u squared minus 35u minus 200 is equal to, oh boy, the numbers are huge. So we can either do quadratic factoring, which is going to get even worse, because then you're going to have to deal with the 200 there. So I'm going to just try some possibilities here. So I need two numbers that are going to subtract each other to get me down to a 35. I don't know. I'm really just kind of thinking through this here with you guys as well here. So I'm thinking 10 and 25, if you add those together, that gets you that'll be 45. 45 and that. No, let me look at multiples of 200. Let's see if we can get multiples of 200. So somewhere in the 40s. That's, I'm thinking maybe the answer is somewhere in the 40s. Alright, the numerator of a fraction is 2 less than the denominator. The sum of the fraction and its reciprocal is 5/2. Find the numerator and denominator if each is a positive integer. Whoa, okay. So here's our working out some problems here. So numerator of a fraction is 2 less than the denominator. So let's work out at least n. Numerator is 2 less than denominator. So I got numerator is n, denominator is d. There's at least my relationship between the two. So it says the sum of the fraction and its reciprocal. Whoa. Is 5/2. Find the numerator and denominator if each is a positive integer. Okay, the sum of the fraction and its reciprocal. So let's start here. So I'm thinking x right here, that's the numerator.